Hey Jeff, how are you doing, man? Long time.
Doing fine. How are you doing?
Good, good, good. It was great seeing you at the Global Summit, I believe. It's first time after that we're talking. Um, I know we are not on the officially on the agenda, but this was long overdue. We have like about 4 slides to present. If I don't know if it's even required, but we're going to submit the contribution for RAS API specification to the steering committee. We'd like
Mhm.
to flash it real quick, me and Drew, to this leadership here.
Yeah, the way the flows go, it's somewhere down in the middle of the process after we approve it. But given it's a work stream, I can throw it in there.
Great, thank you so much because you're like really running this time, end of the year kind of thing. So
You can give me a link to the presentation through the chat.
we'll do. Just give me a second.
Give it about a minute longer here. Emil's out today. There's a lot of folks at supercomputing, so we may have a lightly attended meeting, but there are some process things to go through. The agenda's up there. It's posted. It's the normal. Start with pass downs, updates, contributions, and then go through the work stream and sub-project updates. Give it a minute or two longer. I'm not seeing as many folks, but again, given supercomputing, I'm not surprised.
The link is in the chat now.
Thank you. Scott's here, so we got Fast Verify. Scott, do you have a link to the presentation that you planning on presenting?
Uh, I didn't put it up anywhere
Okay.
yet. Is there a place I should be putting it?
I
I
mean, there's the shared Google Doc drives. If you want to send me a link, I can put it up there. Or your
uh I
or
can
the
share.
contribution. I don't know if they're shareable straight out of the contribution portal or not. John, do you know?
No, they're not.
That's what I figured. Worst comes to worst, I can drag it into the drive and share. All right, let's get going here. It's 4 after. We've got folks here ready to present. As always, this meeting is being recorded. We've got OCP pass downs from John. We're talking about moving DC and debug into hardware fault management.
Yeah,
We've got 3 contributions to go through. Yeah, Marco?
Jeff, on that one, not sure that the making the workstream meeting an ad hoc meeting. I don't think that's yet the
Can
conclusion.
we
So
delay
maybe
that discussion until we get
Yeah.
to
yeah.
the agenda item?
Yep.
Okay,
Yep.
sure.
Then we've got the updates from system GPU, hardware fault management, OpenARM CDM, manageability profiles, workstream, SCIM, and the debug and diags. Anything else to add to the agenda? All right, then let's get going. John?
Pass down. So we had the system management um, workshop for open systems and AI last week. It was pretty well attended, about 100 people. All the presentations have been posted in the process of scheduling workshop number 2 in December.
Is that really going to be held December 9th?
He still wants to shoot for it.
All right.
I give him my warning that I may not be able to attend. So
Yeah, there's probably other folks like that. All right. Anything else?
No.
All right. There you go, Marco.
Yeah, fine. I mean, yeah, so yeah, I mean we basically the only part I'm not sure is the saying that we're moving the work stream meeting into an ad hoc meeting. Essentially, we are um, working out how do we integrate what's done in the DCD and debug work stream into what fault management does, and then make sure we essentially address the items that are haven't been addressed before and are the biggest ROI. So whether that means that it turns into an ad hoc meeting, I am not convinced of yet.
Okay. Yep. Understand. There's some overlap, but not a whole lot. So, or
Uh,
maybe
but
not
it doesn't-
enough.
Yeah, I mean, no, actually, the way Jeff, I look at it differently, right? I think after the overlap, there's still going to be plenty of work to be done.
Sure. Okay. Well, I know we had a meeting scheduled. What day did that one end up being?
It was yesterday,
Oh, it was yesterday.
and then I set up a follow-up for like a month from now, roughly.
Okay. That was
I
the
mean,
one.
basically, there was a recognition of there was lots of charter overlap, and so reconciliation of the charters so they don't overlap is the task at hand. And I
Yeah,
think Michael has the AR to figure out what that charter might be. So everything, all the charters are nicely constrained.
Right.
yeah,
We welcome, that being under the hardware fault management. I think, like John said, reconciliation will help us being more clear about those.
Okay. All right. When you get those charters done, obviously give Himmel and I a heads up.
yeah. I'm currently kind of looking at I've been literally working on it before I got on the call, so.
Gotcha. All right. Moving right along. Next up, usage guidelines for baseline, service baseline, and Ethernet. Nick, John?
Yeah, I need to share. You need to let go.
Oh, okay.
Yeah, it's weird like that. Okay, do you see this?
Yes.
Okay, so so there are three usage guides included in here, and I'll go through them in detail. I'll do them by three separate companies. Next slide is the update of the baseline, a service baseline, and an Ethernet profile, which we've already had a presentation on. Oh, I decided that instead of putting one through the process, we put all three in the process, since all the slides look the same. So the way we do this is that we actually approve a usage guide, and the usage guide kind of drags along the corresponding profile. And the reason we do a usage guide is the usage guide is readable by everybody, as opposed to people who don't want to understand JSON syntax. This is basic content of a usage guide. It has a table of management tasks. It references the profile that's associated with it as normative, and then it has links to specific use cases on exactly what the interaction is across the Redfish interface in order to accomplish that particular task. Totally easy, very straightforward. So it's usable reviewable by people reviewing this, and for the developers, they can go take a look at what's actually supposed to happen across the interface. The method is describing a profile. So profiles you need to enforce the prescription and specific requirements. And the method of prescription is either it's required for entry into the marketplace. It can be referenced by other OCP documents, either base or design, and it can be referenced by other STOs. So in this particular case, the Ethernet NIC profile is proposed to be linked or referenced by the O2 Ethernet import profile. Any questions? Okay, so next is just the task table. So for the Ethernet NIC, these are all the tasks that we've placed in the fundamental Ethernet NIC on which the Ultra Ethernet profile will extend from. This has been reviewed once by the NIC 3.0 group. So it's sufficient for us to pass, and they can decide upon further review whether they want to reference this use case document. This is the update to the baseline. The main changes is that reference model is evolved, and it's gone from a power resource to a power subsystem and a thermal to a thermal subsystem. Lots of people were requesting, can we have either? Can it pass? And so we modified the profile so you can have either, and we've notified them that the power profile is in fact deprecated, and then a couple of entries to make these mandatory. Okay, and then last is the service baseline. So this, the baseline profile makes a kind of a soft reference to accounts and service management, but it doesn't really talk about it in detail. It just says, yeah, you got to have it. You got to have management controller. What service baseline does is go in detail as to, okay, what exactly can you do with these accounts and what can you do with other specific services? So it's got stuff for user accounts, certificate management, event notification, and actually it's quite large. It goes into all the events, all session management. So this is a baseline that once you find a Redfish endpoint, you should have all these services allowed to you. And so the way we plan to structure it, it's not structured today, is that the service baseline would be referenced by other profiles. So currently the baseline, as I showed you, does not reference it. The plan is to roll the baseline and actually reference the service baseline. The PowerShelf and the liquid cooling baseline already references it. So that's why we need to get this out so we can come back again and release the PowerShelf and the liquid cooling baselines. Any questions? Okay, and so the last slide is contribution tenants. So all the contribution tenants for all three profiles are identical except for impact. And so the impact is listed here for the baseline. It's a requirement to get into the OCP marketplace. You have to conform to either baseline or the server. The service baseline provides us a very common set of manageability for any Redfish endpoint. And the Ethernet NIC profile gives a common manageability for Ethernet NICs from which Ultra Ethernet could be extended. I didn't put the Ultra Ethernet portion in here because it hasn't been done yet. It's still a proposal. Any questions? Okay, then I'm done.
Great,
Okay,
John.
thank you.
Thank you. Any comments? All right, next up, Scott, you want to do Fast Verify?
Okay. Okay. Okay, these are the slides I gave at OCP. Basically, Fast Verify is a lightweight automated testing framework that we developed for Linux platforms. The goals of it are being easy to use, easy to integrate, portable, modular, and it uses JSON YAML type formatting. Oops. So we originally started working on this on our 8501 platform, and the main goal was that we had to run CentOS 9, which was raw CentOS with updated Linux to include customer profile and utilities. And we didn't have a unified infrastructure to do that on. If we ran Sonic on it, which we also did as well, we had Showtech and other useful tools, but we didn't have that, and we didn't have DIAGs. So we created this to kind of tie all the pieces together. This is basically why high-level verification matters, right? So it's an ability to write quick tests for like go, no go, further testing, capture the output of all commands. So I use this at manufacturing so that I can grab everything and keep a record. It's adaptable to different types of testing. It runs mostly standard command line programs. So if I want to enhance it, I can write a separate program and then plug it in and check the output as it verifies the return code and output. This was inspired by the 8501 product, which is a 64 by 800 gig product. So what is it? It's a lightweight automated testing framework. It does high-level validation. It's really meant to be written on Linux or used on Linux open source platforms. Our key design principles on this were portability as we wrote it in Python, modularity as test cases are written in JSON, and it's easy to integrate as you basically are calling command line programs. And of course, since the output is also given in JSON file format and the results are basically text files, it's easy to go through with a web server or UI or something like that. So portability and customization, minimal config changes for customization really depends upon where we need to extend it for whatever the use cases are. The use cases that I've used this for are multi-step processes, streamline multi-step processes, encapsulating them in scripts, eliminating manual copy and pasting from documentation. A lot of times I'm trying to follow steps and there are so many steps and in the middle, if you mess one up, you're kind of in trouble. But if we put them in this format, then basically run it through and you don't have those problems. Quick regression of systems. I use it to, if I build a new image, if I change something, I can quickly validate if high level things are good or bad before I go start testing something in great detail. And of course, we use this in our manufacturing for the 8501 as kind of a final check before it gets shipped. I have all the test cases in there that I'm looking for. And if something goes wrong later, I'm going back looking at the logs the output of the logs from the script. And so the workflow for this is basically we take the test inputs as JSON YAML files, we run it through the FastVerify engine, and then we'll look at the outputs, raw files, JSON summary, review what's happened, and then feed it back and update. And that's a circular, very common pattern. So comparing it to different architectures, right? FastVerify's the primary goal is high-level validation, quick go, no-go, sanity checks, repeatable operations. Traditional DIAGS is going to be more detailed, component level, verifying libraries, APIs, hardware. Traditional show tags will gather a whole lot of data for troubleshooting, but doesn't necessarily tell you the state at the moment, right? Level of detail. FastVerify is kind of a high level validation, whereas traditional DIAGS will go really deep. And then I think of traditional ShowTech as kind of a snapshot configuration of where you are. Portability. FastVerify, since it's written in Python and uses JSON YAML, is pretty portable from platform to platform. Traditional DIAGS is often written in be architecture specific and less portable. And then, of course, ShowTech is really dependent upon the OS or the device or the infrastructure that it's written on. And of course, the strengths and weaknesses I kind of talked about as I went through. Let's see. So yeah, I kind of think of it as before FastVerify, things are kind of a mess, and then they just kind of flow through nicely with it. This is kind of what the test vector input file looks like. So I specify what the base directory of where the output is going to go. I keep everything in an error log file. And then basically by groups. So for example, the default group would be command lines. and then commands, and then each of the elements would be what commands it runs. So command would be the command that it runs. And then it would be file would be where it puts the output of that. And then of course it's looking for these strings for fail. If it would fail if it sees 3. It ignores a line that has 2. It'll pass if it finds 1. And of course this one would fail because it would see 3. Oops. And it checks for return codes of 0 or 3. I have it typically default to check return code 3. So if you left nothing, it would just check the return code of 0. And then of course it can call other groups. So output and reporting. This is what the output would look like on the left as it runs along. It kind of gives a running output. Of course, there would be one fail at least from what I was showing up above. On the right is the output in JSON file format that has all of the stats and pass fail and tests that were run. So roadmap and source plans. So looking for feedback, of course, trying to innovate and keep things going forward. It's currently in GitHub under this Git repository, which is what I'm promoting here to try and get released. And I did create a short demo. I think I'm talking really fast, so I'm probably going to be ahead of time than behind time. I apologize.
No, you're doing fine. Don't worry about it.
So
We're
this is
keeping up with you.
Huh?
We're keeping up with you.
Okay. So this is the output as it's running through. It had the input file. This is the output. Of course, this is a very, very, very simple input and output file. Just running things like uptime and echo commands. And of course, it prints here the number of passes, fails, and JSON file, which will come up in a second. Here's the JSON file, which shows number of suites is the number of groups that I have, the total number of tests, of course, how many passed, how many failed, what the percentage pass rate is, and then the tests that failed and passed. And then in a minute, I also bring it up in a browser as well to show that you can kind of see this in a browser and open and close all of those as well. So this has all the same stuff except for in a browser, which sometimes is a little bit easier to kind of go through and read and look at, but also showing that it can be pretty easily parsed by simple JSON or YAML browser or parser. Okay. Then call to action. So this is just a simple use case. Other use cases can be anything where multiple steps are required. As I said, I use it for building images, validating images. Anything that combines a bunch of cumbersome steps can be useful. How to get involved is proposing it like I am here. Check the sample code provided, find new creative ways to use it. And of course, I have a link to the GitHub again. And I converted these slides basically last night from what I did for OCP to this format. So it is a little bit different. And I kind of squeezed things and pushed them around as best I could. And then the summary and QA. So the key takeaways is easy to use, portable, modular, as I stated before, using JSON YAML, which I think is kind of one of the best parts of it. And the value to Cisco and OCP users is it's easy to adopt, easy to use, and it's very extensible. And with that, I'll leave it open to questions. I was just thinking about it, and based on the last presentation, I was kind of trying to throw this in here at the last minute because I forgot about it as I was doing this at the last minute, kind of converting the slides from one to the other. So I apologize for not having this all filled in. But with that, I'll leave it to questions or comments.
So I've two questions. One is, does this run on the unit under test, or does this run on a system outside the unit under test?
I run it on the unit under test, so it doesn't have the ability to do reboots and things like that.
Okay.
Although
And
it could be, let's go ahead.
oh, and the second is this a test framework or the actual test? Because if I take what's in the repository and I run it, does it test anything, or is it just a kind of framework I can attach stuff to?
It's more of a framework.
Okay. All right.
Because yeah, it'll run the various things and validate the outputs from those, but it's not going to have the test itself. Yeah.
So does it then specify how to invoke the test and what the results from the test need to look like? And then summarize it? Is that the high level version
Yeah,
of what the
so
tool
That's
does?
it.
yeah, I would specify the commands kind of this way, right? So where here uptime would be a command that I wanted it to run. So for example, I think the vendor that I was working with, I had to run commands like validate hardware fan tests, and they would give me a binary, and I would run that command and look at the return code and errors out from it, right? So
Mhm.
I could check for those errors using this sort of way. I could check for E1, for example, and if I saw that, then I know that's an error in the output. If it returned an error code that was non-zero, I knew it was a failure.
So it's invocation by command line.
It's what?
It's an invocation by command line, right?
Yes. Yes.
So okay, so you essentially evoke a command line tool and then you standardize what the return codes look like so it fits into the bigger framework. Do I see that right?
Yeah. Yeah. Invoke a command and then check the return code and the output.
Okay, cool.
Yeah, exactly. And then some of the other things, I think right now I don't have a stop on failure, but that was one of the things I've been thinking about recently. Um, is a way to stop it on failure so that way it doesn't keep going. Because once you have one failure, depending upon where you're running it or how you're running it, everything else can continue on failing, or um, uh, you can get weird results after that, right?
Would you make that like a global flag or something that's
Yeah, I'm
different
probably
from
like in the
command to
beginning
command?
here,
Yeah.
stop on failure, or it could be a flag in each command or like a flag like this as well. Probably one or the other or both could be useful at various times. For example, I have one script that I use it for, at least myself, that I pull a workspace. So if the clone fails, then trying to CD into it and build from it doesn't make a lot of sense. Great questions, by the way.
And then I mean, one comment to the stop on failure that could also be like um, a property of a given script, right? Some may be able to run through, and some might just inherently need to break on failure, like what you were just describing, right? Like
Yeah.
if my first step is to set up some environment and then interact with it, then that's just that script will not continue.
Yeah. Well, one case where I use it, for example, in um, validating, right? Validating my board. I wouldn't necessarily want it to stop on failure because if it fails getting the MAC address out of the I210, I don't really care because I'm also looking at the EPROMs. So if that's the only thing that fails, then hey, maybe there's a problem with the I210, which I have seen actually.
Any other questions? So how are you maintaining the open source?
So far I put all the code that I have done so far up in the Git repo that was presented to me earlier. And then as I update, I can continue to push up there.
Okay. What about like issues and polls from any interested parties? You take care of those yourself, not part of a work stream?
Yeah, probably myself, because I think right now it's mostly me.
As long as people know.
Uh,
As long as people know how to deal with it.
yeah.
Great. Great. Any
Yeah,
other questions?
what
Go ahead.
yeah, what we're looking at is adding a governance document markdown onto the repository so people understand how particular repositories are being governed. And it's fine for the project leads to say, go ahead and govern this repository yourself until such time as you guys decide that it needs more official governance, like a work stream to govern it.
Right. Reaches critical size. Yeah.
Yeah, yeah.
Cool. All right. Thank you very much.
Okay. As far as publishing the slides, should I just I think I'm on an email thread with you, Jeff. Should I just email them to you for the near term?
That'll be fine. I went to try and find the flow for this, and the links I have don't work, and I can't find it in the tool anymore. So I'm sending an email to figure out
Okay.
what happened. But
Yeah,
if you just want to reply to that and send it out,
Okay. Yeah.
I'll
The
put
flow
it in
had
space
an
and make
earlier
it.
version. Sorry, go ahead.
Oh, that's fine.
Okay.
Yep. Okay.
Thank
All
you.
right. Well, you bet. Thanks a lot. All right. Next up was RAS API. Y'all are getting close to 1.0, I take it.
We're getting there. So I think Yogesh is going to share, and Yogesh, you're muted.
Sorry, double muted. Can you see my screen or?
Yes.
All right. Great. Yes, Jeff, that's right. Getting close to 1.0. This spec release is a lot about what it is not. As you know, we're lucky to have both Drew Walton and Antonio on the call today. They contributed the first version of it, which was very ambitious, but unfortunately, some of the industry players felt like it does not work very well with how they want to do things. So we worked very hard. I'll go through that to re-abstract it and make it truly agnostic. So I only have about 6 slides. Agenda, as you can see, I'll give a brief overview, what we changed, and then go to the backup. Okay. So I'm not going to read this busy slide. As an overview, basically RAS API, as you know, defines a standard abstraction interface between the data center devices and the management software in the data center. It supports all the features shown in the picture: discovery, RAS configuration, error logs, RAS action back to the devices, as well as error injection. And it does it all by defining, standard data structures and commands, which are based on the existing industry standards. It intends to support both in-band and out-of-band usage models. I'm going to continue to move on. As you see, this slide is busy, but it's self-explanatory. Like I said, this version is a lot about what it is not, so we can have the entire industry truly with us. So we have rewritten and abstracted, cleaned out for it to be truly agnostic and extensible via various industry standards. Some of the examples are quoted here: ELDM, Redfish, CCI are primary ones. What we did was we redefined the agents, the endpoints, the initiators for the RAS API actions, and we also defined capabilities, like I mentioned in the previous diagram, which primarily discovery of the endpoints, configuration of the endpoints. We defined the structures of the error reporting queues, classifications of the errors in those queues, which also align with industry standards, by the way, and also the action queues for the data center to send actions back to the hardware nodes. We also defined a new data structure for actions, which doesn't exist today. For error logging, we fully leverage Eufy specified CPER logging, and that enables us for the time series analysis and fluke tracking. Also, for like I said, we define a new data structure called CPAD that allows us routing the actions back to the corresponding devices. Moving on, a little bit more. Again, I'm not going to read fully, but a little bit more. CPAD is really, in a way, very similar to CPER. It leverages CPER in a big way. As you can see from the diagram, it has same general structure, header, record header, section descriptor, section body, and whatnot. The payload of that is defined as an action that is to be executed by the command. That is also part of the payload, and then we support standard actions as well as vendor specified actions, because that's critical for innovation. Various vendors come up with new RAS actions all the time. There are some differences. We defined some new fields which were not existing in CPERs, but hyperscaler fleet community felt that they needed a certain degree of severity and urgency, and also classification of action IDs. So those were added on top of CPER. Command categories that we are defining generally fall in three categories. First is endpoint related commands. Second is error event queue management commands, and third is action queue management commands. So endpoint related commands basically help you discover the endpoint, retrieve and modify their capabilities, and basically it's mostly config data that flows through those. For the error event queue management, it allows queue configuration, it allows retrieval of error logs, and uses CPER for that, and as well as config data also as part of the payload. For action queue management, again, it allows retrieval and modification of action queue configurations, and also to send action requests to the endpoints or data center nodes with CPAD and some config data.
And Yogesh, could I just add something really quick to that?
Of course.
The notion of the RAS API is that I can write a tool that will make a request that says, give me your CPERs, and it will get the CPERs from all of the silicon in the system in the same queue. So we can write what's effectively a universal collector that remains constant across silicon vendors and product generations. The data on the pipeline can be proprietary and can vary per chip, but the pipeline itself is standardized, and the way to drive actions back to that silicon is standardized, so that it becomes much easier to incorporate new silicon into data centers. Thanks, Yogesh.
Thank you, Drew. That's really good clarification, and you did the drawing.
Yogesh, Drew, I got one question.
Sure.
So what do you see as the scope of a CPER? Is it an error record? Is something like a crash dump still a CPER, or maybe a debug dump? Would we wrap that into a CPER and treat it as something that's part of RAS API, or does it become something different?
Yeah. So the problem we have today as a hyperscaler is that crash dumps go down a different pipeline from corrected errors. If the corrected error was related to the crash dump, it's really hard to correlate. And then when we have an unexpected problem with silicon, building on-the-fly debug infrastructure to collect debug dumps is brutally difficult. But that's what often happens, and that slows our debugging efforts even more. So what we're proposing is CPERS with a common pipeline for all classes of errors, including debug dumps and analysis tools that will analyze many of them. And when we get a debug dump, we don't expect the analyzers to analyze it, but we expect the analyzer to recognize that and say, oh, you've gotten a debug dump. You need to call Intel or AMD or someone else to get them to look at this dump to figure out what it means. But that's exactly it. One pipeline for all errors so that we can correlate them and analyze them in one place.
Marco's short answer was all of the above. Okay.
Okay.
So moving on, here's a snippet from the table of content, what's included. Besides the required content, we have in the basic specification abstract interface, which includes discovery commands, configuration commands, queues description, queue management commands, and also we created separate queues for events from errors, so event reporting queues and action queues and action queue management. As far as data structures are concerned, we are leveraging CPAD as it is from UFI. We are defining CPAD. So in CPAD, this general format, header description, section descriptor description, section body description, it's all covered in this version. And then we have still substantial amount of future work that we have identified. But like I said, our major goal, our non-goal was not to put out a complete spec, but our major goal was to clear up air so industry can align more with us and more progress can be made. So we wanted to really communicate what is in the last spec, which is not applicable anymore. With that, we will briefly flash how we meet the OCP tenets. Openness, it's open CLA licensing. Everyone is welcome to join. We have pretty good membership, and that's one of the reasons. Progress slows down a little bit, but we also at the same time guarantee that we are putting out a bulletproof spec because it's really broad. It's really broadly accepted in a true sense through a lot of debate and discussion. It uses standard data structures, UFI CPER and CPED as defined, so it's definitely efficient in creating vendor agnostic solutions, software for fleet. Its impact is, of course, enabling rapid fault insights, analysis of all sorts, for example, time series, innovative solutions roll out even after in the fleet and across, and giving kind of a democratized interface for small or big vendors or across the silicon generations. And of course, it is designed to be scaled based on the standards. It is definitely very scalable. It's basically all the hyperscalers have put in a lot of thought in that. How does it scale? How does it work in band, out of band? All sorts of solutions at scale. And that all naturally leads to sustainability because it really helps with keeping system up, enabling system uptime, rolling out new features in the fleet, so that extends the life of the fleet itself. Those are some of the top highlights of the tenets, and I think that's pretty much all I have. We can thank you very much for opportunity today and any feedback.
Yogesh, do you have a link to the current version of the spec that you can share?
Yeah, I can share that too. Let me put that in the chat window.
I can do it for you if you want the RC version.
Yeah, RC version. You want to do it, Drew?
I've got very handy. So
great, thank you so much. And I have a couple of slides in the backup. At the same time, we are working on a proof of concept, which basically demonstrate that a fleet control plan can do a round trip to the hardware node in terms of fetching all sorts of error logs, including what you have, crash dumps, error queues, and then make a round trip back with the CPAD driven RAS actions. So that's something that we're working with 2 or 3 different protocols. There's a redfish model that's going on. Some folks have started on PLDM-based solution just to see as a proof of concept that works for them. So that's great news. And that's all collaborative. Silicon vendors are all included.
So,
great idea.
so Yogesh,
Mhm.
is the intent to upstream the open BMC code?
That is the intent. Yes, we intend to create these and release them as a kind of sample code for anyone to
Well, and our sample code will initially just be a fake BMC that runs, and it's not always like a simulation of a BMC that people can write software against and try it out, and then we'll merge it into OpenBMC as we get the Redfish interfaces ratified.
Exactly. Yeah, initial version is going to be really skeleton, but I like to say. And then
we'd
sorry.
like to release it on GitHub so that anyone can kick the tires once we release the spec.
And the last slide is basically showing how RAS API is part of the big hardware fault prevention requirements framework that we all have been working on for the last few years. Yeah.
So what's the different? What's holding up 1.0? What else are you going to add? Or are you just waiting for experience?
There is still some areas of contention to be cleared up. One of them was, and we did not want to really delay too much. Like I said, the major goal was to clear up the error of what it is not. So there are still some discussions, for example, about timestamps, for example, about what IDs to use for through text. Some of the finer details.
Oh, I guess the other big thing is discovery too. We need to work through some of the discovery semantics.
Yeah, that is another big one. But in terms of the basic capabilities, I think there's still a little bit. We could call it like 1.0 at that point. Once we have all the structures and commands complete, Jeff, we can call it 1.0, and then we can add more capabilities in substantial subsequent versions. For example, error injection framework, right? That could be part of the later commands for error injection. But I think error retrieval and action is the minimum we have set as a target for 1.0, and that's why it's still at 0.9, because we have just a couple of more things, but we did not want to lose this year's release, and because I think because of being open and having a lot of participants, it takes a little while for us to come to the consensus.
Sure. All right, thanks.
Do I get one more question on the discovery? Do you see that as a specific discovery for the REST API capability, or is there a bigger fault management scheme that we may need to look at?
So the goal is that, and like this is what we're going to also work on in this simulation that we're building. The goal is that we can query a machine and we can see all of the silicon in it. So if you have 8 GPUs, a SmartNIC, 2 SoCs, and maybe even a voltage sequencer or a PCIe switch, we would see that those exist. We could configure the RAS features on them. And then when we say, give me your CPERs, we collect their errors from the queue. And what we've done is we've embedded in CPER, using the existing CPER standard, enough routing information that we can tell which of those chips sent the error log. So when we send a message back to the machine, we can take action on it. But when we discover the chip, we need to configure it. And we also need to be sure that we've got an analyzer that can analyze the data we gather from it. And so I could find out that, well, this uses the Intel Analyzer X or the Intel Analyzer B, or this one uses an AMD analyzer or an Ampere analyzer. And so that's our goal, is to associate the endpoints of the analyzer, configure them, and then be able to do that round trip between the collection infrastructure, the analyzer, and back to the SoC. So did that answer your question?
Yeah, partially. What's floating around in my head is, as we were working through the diagnostic and debug things, where we also need a similar discovery scheme to, let's say, we have components that we can do interactive debug to. We would obviously got to discover that too, and it feels like maybe these two flows, maybe that should be really one infrastructure. That's where my
Well,
head's at.
the way I've been also looking at other diagnostic efforts, and the way I would put it is that in terms of gathering error logs, we don't want like a giant complex thing to walk through. We just want to say, hey, BMC, do you support the RAS API? What endpoints are you abstracting? But when it comes to diagnostics, if diagnostics are interested in hardware errors, which they generally are, then this would be equally applicable to monitoring for diagnostics. And I would strongly encourage people implementing diagnostics to consider using some of the error analysis tools we're building.
Mhm.
Because if you
Yeah,
get out, you need to figure out what it means, right?
Yeah, and I mean we should, like, the worst thing we could do is have like two parallel frameworks that are, you know, are full of touch points and some level of overlap. Right? I really don't want to see that.
Well, I think we're synchronized within Microsoft with the folks working in the diagnostic work streams we're participating in. But maybe we're not synchronized with some broader folks. So, if you want to chat with us, we can work with you. But I think
Yeah.
the important thing is for field monitoring, we've got to keep it simple so that we can write a universal collector.
So
absolutely.
I hate
Absolutely.
to interrupt the discussion. We got about 5 minutes left, maybe 7, and need to go through some work stream
Oh,
updates.
sorry, Jeff.
No problem. It's fascinating. Never mind. Just code and working through OpenBMC and all is, I think, germane to this audience. So it's a good discussion. But there's some other folks. So
Thank you, Jeff, for the opportunity.
Yeah, thank you.
you bet. All right. So updates. John, you got anything on system GPU management?
No, we're just going through the issues at this point. There's been over 30 issues filed against the GPU spec. So that's it.
Great. Hardware fault management, everything else? Yes.
Just one of them, but yeah, on hardware fault management, we are working on new stuff now. That we have 1.5 under belt. Error classification, severity classification discussions are going on. There are a lot of different things that are going on. I don't think I need to bore you with that. But the bigger thing I think we are trying to do is to we had spent like 3 weeks seeking feedback on industry pain points, and our meetings are pretty busy. We have 20 plus people, and we scope them out, we prioritize them, and we came up with our plan for the next for the future. I don't want to put a strict timeline, but I would say at least next year or so. So that's one big activity Drew was driving for last 3 weeks, I think, ever since we came back from the Global Summit. And I think he's sharing that spreadsheet also.
Yeah.
It's pretty open. We invite everyone's feedback. We don't take decisions behind closed doors. We can take the heat. On the fleet memory fault management, we are working on now that spec version 1.0 is out. We are working on some of the scenarios, and what scenarios are really kind of an implementation example, how to put it in practice. And we're doing that with DDR5. Some of the things that we proposed, like how we did for hardware fault, how to handle Drew presented how to handle poison, and here we're doing how to handle memory errors leading to things like page offlining and whatnot. In addition, we are getting ready for the next phase where we pick either LPDDR or HBM and work on specifying error logging under fleet memory fault management requirements for those. So that's it. Sorry.
All right. Cool. Thanks. Moving right along, OpenARM CDM.
Yes, so some quick updates. So the first one is in OCP and after OCP. So we got some feedback regarding the use case about the scale domain, especially some requirements say we probably need a new interface with instant response, and Ethernet might not be fast enough. The second is the people might have some use case talking about how to leverage the BMC type of silicon to handle telemetry, more telemetry, and also how to handle some predict failure model. Yeah, so we're gonna have some invite talk in coming, hopefully December and in January to talk about. So regarding the sub-project itself, so for OpenMC 1.2 spec, so right now Brian and John gonna working on closeout. I think the last piece is a redfish model for some use case. So we probably try to review on December meeting. So for after that, so we're gonna kick off the 1.3 spec, and we start to put some new cases, and we might have some invite talk regarding more use cases, especially for telemetry part. Yeah, that's a quick update.
Appreciate that. If you're ready before the December meeting for the 1.2 presentation, let us know.
Okay, sure.
Cool. Manageability work stream, John, any updates? You just presented earlier, so I guess not.
No updates.
All right. Skim, Jim?
Yeah, I had to come off mute. Had a lot of good comments and some enthusiasm from the talk I gave at Global Summit. We're seeing a little bit of an uptick in participation. We started talking about the semantics for aggregation of multiple nodes into looking at and doing math reduction on the same particular metrics. We've also started, I've had at least one good meeting with Jeff Otter working on trying to figure out the alignment or closeness of Redfish's telemetry specification and what we're doing in the Skim group. We're at least playing some preliminary footsie with the DMTF PMCI group, who may or may not be working on some additional standards in the area.
All right, thanks for the update.
Sure.
Diagnostics and debug, we talked about the charter and merge. Was there anything else you wanted to discuss?
But so I mean, where we at, right? We've got kind of I would say we enumerated what all debug activities must be specified, and basically what I'm doing right now is kind of see which of those are covered by some other work group in a sufficient way. So and then find out basically the ones that aren't, and that's where the work's going to start. And then with that, we're going to morph the charter.
All right, thanks for the update. Boy, good timing, everybody. Thanks for being expedient. It looks like we are at the top of the hour. Does anybody have any last minute comments?
Thank you, Jeff.
Right. Appreciate all the work. Thanks for the updates.
Thank you.
Bye.
Bye.